Hi there, everyone. My name is Joshua, and I'm really excited to talk to you today about Transformers.js. So first up, a little introduction. Starting with who am I? Well, I'm a 25-year-old machine learning engineer from South Africa, and one of my main goals when I joined Hugging Face in 2023 was to bring the power of machine learning directly to the web and to your browsers. One of the missions at Hugging Face is to democratize good machine learning, and incorporating and expanding our Python libraries and our ecosystem on that front to the JavaScript developer community was really important, and that is where this project came from. So, and lastly, I'm very passionate about open source, creator of, Transformers.js, Kokoro.js, Ginger.js, I think you see a pattern there, and a few more. So maybe a quick step back. What is Hugging Face? Well, Hugging Face is a platform where the machine learning community is able to collaborate on models, datasets, and applications. We have a very large community, a very large and growing community, and if you have any models, datasets, or spaces, or applications as we like to call them, we'd love you to join and share those demos on our platform. So yeah, if you want to search for models on the Hugging Face Hub, we have around 1.7 million pre-trained models that you can search for. We have a bunch of filters and tags that you can select to basically filter down your search from the 1.7 million to something you're really looking for. It stays up to date, and of course, you can select the Transformers.js library tag as well to ensure that you can see which models are compatible with the Transformers.js library. We also have a large selection of datasets. So in this demo, you can see that if you have a dataset you'd like to view, you can go to the dataset viewer and then even interact with it with natural language, and then that'll be converted into a query where you can basically select data in an interactive way from the dataset. And lastly, spaces, which is what we call our application directory. You can also search for, if you want to, let's say, generate a 3D model from an image, then you search that in the interface, and it'll pop up with something that you can use. And this is where our community really shines. We have a very large community of people who really want to showcase their applications, the models that they've created. And this is the best way that people have been able to showcase their models directly from the browser. And we also maintain a large collection of open source libraries. You may be familiar with the Transformers library, diffusers, safe tensors, tokenizers, just to name a few. But today we'll be focusing on one in particular, Transformers.js. So what is Transformers.js? Well, Transformers.js is a JavaScript library that allows you to run state-of-the-art pre-trained models directly in the browser. The goal is to make it extremely easy to use, allowing you to create and add machine learning functionality directly into your web applications with as few as 3 lines of code. Of course, I mentioned before, we're fully open source, publishing everything on GitHub, and it's very community-driven development. So people would like a feature request, they make open up an issue on GitHub. We love the community when we're able to collaborate in that way. Just another indication of the growth over time. So this is our unique monthly users of the Transformers.js set of models. We're at around 1.4 million unique monthly users currently. And this is basically up double from what we saw around 6 months ago. And the trend is continuing upwards. We're really, really grateful for the support and the people who have been able to create really cool applications with the library. And also, just a little bit of development timeline for those interested. It's a relatively new project, so the idea was basically to, the origin of the library was to basically take a pre-trained spam classifier that I had created in my spare time, and I wanted to run it as a browser extension. Unfortunately, nothing really existed at the time to allow me to do so. So the next logical step was to do it myself, to basically try get my pre-trained model in the browser. There were luckily a lot of really great libraries that I'll tell you about shortly that really allowed me to put everything together in a way that allowed me to run the model in the browser. The V1 release of Transformers.js happened in March of 2023, and at that point, we only supported around 5 different architectures. but as you'll soon see, the number slowly and then quickly started to grow. So next V2, the next logical step was to do a complete rewrite from CommonJS to ECMAScript. And at that point, maybe like 2 months later, we were at 19 supported architectures. And then V3, which is our largest release yet, was basically introducing WebGPU and WebNN support. And then we were able to support 119 different architectures. And then where we are currently, we're at around 155 different architectures, and there's a lot of things planned for the library, which I guess I'll cover shortly. And once again, just a huge shout out to our community all over the world, creating demos, contributing to the library, and posting to social media about what they've created. It's really, really, really great to see from our side as well. So thank you. And one more set of slides on statistics. We're at around 1 million NPM downloads in the last 30 days. And at the bottom, number of JS deliver CDN requests for those who don't want to install via NPM. So what can Transformers.js do? Well, we support a variety of tasks. We like to classify them into like text, vision, audio, and multimodal tasks. And you can see some of the lists here. Like I mentioned before, we support around 155 different architectures across 27 different tasks. So whether it's like text classification or, let's say, speech recognition, text-to-speech, those kinds of things. And we have around 1,850 ready-to-use models on the Hugging Face Hub. So as you'll soon see, you just have to replace the model ID with a model that you like or that you're fine-tuned, and you're able to hopefully run it in the browser. We also have really great integration in different browsers. So Chromium-based browsers have really good WebGPU support, for example. So Chrome, Edge, Brave, browsers like those. Transformers.js actually powers the the Firefox AI runtime in collaboration with Onyx Runtime. And then lastly, Safari, which actually just a few days ago announced that WebGPU support will be shipping in Safari 26 beta. And that means that it will be able to run Transformers.js models in Mac OS, iOS, iPadOS, and even Vision OS, which is really exciting. Just a few benefits of why you'd want to run models in the browser. So number one, security and privacy. Since none of your data, and especially none of your sensitive sensor data, like microphone or camera input, gets sent to a remote server, everything happens locally. Of course, real-time applications is a huge benefit because there's no network latency. Let's say, for example, real-time background removal, you don't have to send a picture of your screen every single frame, which would just be completely it just does not make sense. And then lower costs, both for developers, because they don't have to pay for inference or server costs, and then also for the user, where you're using your own compute, so you don't have to use API keys or anything like that. And then I think a huge benefit of distributing over the web is that it's highly scalable. All I need to do to share an application with everyone in the audience today is to give them a link, and they can run it on their device. And another reason, like you may have seen a few days ago, is when OpenAI or ChatGPT was down for quite a few hours. So that's another benefit of running on device. And then also, we greatly benefit from the versatility of JavaScript. So as I mentioned, we're able to run in browsers, but that's only one part of the story. We have support for, you can run in Node.js, Bund, all these different runtimes, your favorite libraries or frameworks, whether it be React, Next.js, Svelte, Angular, all of these. And then we have support for different build tools, I guess. And then, of course, the environments, where you can basically, if you want to run in a web worker, as a browser extension, serverless in maybe like super-based edge functions, or desktop applications with Electron. Those are all possible. We're also working on native WebGPU execution in collaboration with Onyx Runtime and Onyx Runtime Web, which will greatly improve support for GPU-accelerated applications, for example, in your Electron applications or let's say, an edge function. And then another goal of ours is to be able to implement and run in React Native with GPU support as well. But those are some things we're working on. Quick slide on how does it work. So you first take your model that you've either trained in Python land, or you can use one of our pre-converted models. And there's a few sets of libraries like Optimum or Onyx Runtime GenAI that you can use to convert your models from PyTorch, JAX, or TensorFlow to the Onyx format. And Onyx stands for Open Neural Network Exchange. It's basically a format that allows for highly interoperable machine learning experiences. And then you write your JavaScript code. So in this case, just a few lines of code to run Whisper. And then behind the scenes, it uses Onyx Runtime to be able to run your model in either WebAssembly on CPU, WebGPU on GPU, or with WebNN on CPU, GPU, or NPU. So let's see how you would start maybe adding ML to your web applications. So just a few lines of code. Number one, you import the library. Number two, you create a pipeline. And then number three, you run it on some input. And you're also able to specify a custom model. So as your second parameter to the pipeline function, you can specify the model you'd like to use. And then some other options, so you have the initialization parameters, so if you want to specify whether you want to run on GPU, so WebGPU, as well as quantization settings like Q4, F16, that's in the first step. And then in the second step, add runtime parameters like the maximum number of tokens that you'll be generating. A quick little overview of what WebGPU is. It's meant to be the successor to WebGL and is a new web standard that allows you to run it's a modern API for accelerated graphics and compute. And more importantly, it's a general purpose API, which means that we can run machine learning operations, which is really, really important. And you can enable WebGPU support by just specifying the device as WebGPU. It's a little bit limited availability, as I was mentioning earlier, but we hope to see browsers move towards better support in future. And then WebNN as well. You can also specify the device by saying WebNN, either maybe if you want NPU, GPU, or CPU. You can also specify that in this case. And then a quick slide on what quantizations. You can because it's very important, because browsers are extremely resource limited, we encourage users to quantize their models and reduce the precision in exchange for lower resource consumption, lower memory consumption, and lower bandwidth to the user, because they need to download it once, and then lower memory consumption at runtime. And then we also expose different maybe APIs that users would like to achieve a little more control. So for example, a segmentation demo like this. Maybe some factors to consider as you are developing for the web. Bandwidth is important, so the user needs to download the model once, so you encourage them to choose models that can run on the target hardware. Accuracy versus speed, what level of quantization are you going to use, and what latency and precision is required. Device features, what browser APIs are required, maybe microphone input, and WebGPU support is one of the top ones. And then target devices, are you building for mobile, desktop, and anything in between. Maybe just a quick run through of some applications that you can build. So of course, privacy-focused chatbots. Being able to run LLMs in the browser is maybe not new now, but the performance we're able to achieve is quite remarkable, especially on WebGPU. So in this case, a 4B model running at around 90 tokens a second on an RTX 4090. And then on this Mac here, running a 1.7B model at around 130 tokens per second, which is really great to see. Really major improvements, and major improvements still coming. We've got, with the native WebGPU EP, I think there's a lot of improvements that we can still make. Real-time captioning, which is an example of taking a webcam input and using a vision language model to describe what you're seeing. We're using small VLM, which is a model that Hugging Face created. And then we also support reasoning models. So if you want to enable like DeepSeek R1. This is a distilled version of DeepSeek R1. And it actually performs, according to their benchmarks, at the same level as GPT-4o on different math benchmarks, which is very surprising to see like a 1.5B model performing at the same quality as some of these much larger closed source models. And then multimodal applications, so basically having text and image input and then text and image output. So in this case, generating an image of a fox, like this is running locally in the browser. And you can also take an image and then, let's say, convert this image of LaTeX to the LaTeX code. Various other multimodal applications, like captioning, we also support. Speech recognition with models like Whisper is a very important and powerful, but also popular use case that people have been able to develop cool applications with. Text-to-speech with models like Kokoro, which in this case is a very small 82 million parameter model. I'll play a quick demo of the quality.
Kokoro is an open-weight TTS model with 82 million parameters. Despite its lightweight architecture, it delivers comparable quality to larger models while being significantly faster and more cost-efficient.
And so significantly better than maybe the robotic voices that you might be familiar with traditional browser APIs. We also have background removal models, which, like I mentioned before, it's one of those canonical examples of why you would choose in-browser inference. Image editing with models like Segment Anything. This is, people have actually been able to create Figma plugins that utilize Segment Anything. And in this case, it's only around 15 megabytes in size. So being able to run that in the browser locally is really great. And this is running in real time here. We also support a bunch of educational use cases. So being able to visualize the attention mechanism in vision transformers, being able to see what the models are focusing on. That's another example. Everything's running locally. And other educational tools like tokenization, like how tokenization works. Being able to run that locally is also a great use case. And also being able to visualize the models. So if you want to, I'll skip forward a bit, being able to dissect and really go into detail of what the models are how they're built. And this is powered by Netron. We also support mobile and desktop games. So in this case, it's a simple image classification model. And so you draw to a canvas, and then the model predicts what you're drawing. And the goal of the game is to, it's similar to Google Quick Draw. So it's the goal is to draw as many items as you can in an allotted amount of time. Another example, object detection. We have depth estimation, many normal vision applications. Music generation is another one. Quick sample, lo-fi music. And one other one I would say is very important, and it's a very simple use case of semantic search, taking raw data, whether it's image, as you can see on the left, or audio, and being able to convert to embeddings, and then being able to do semantic search at runtime. And then this is a demo, the most recent demo, which is a conversational AI. And we will try run this. I remember what I think a previous talk with Thomas was, if the demo works, we applaud, and if it doesn't work, we applaud louder. So let's see if it does work. We're going to pull it up.
Hey there, my name is Hart. How can I help you today?
Hey there, I'm on stage at JSNation. Can you tell me a joke?
Sure, here's one for you. Why don't programmers like to watch old movies? Because they're too bugged to sit through.
Okay, now can you tell me what the capital of Netherlands is?
Sure, the capital of the Netherlands is Amsterdam.
And now I want you to role play as Santa, and I'm going to be a little boy asking you for a gift.
Okay, I'll be Santa. What kind of gift are you looking for?
Could I have a lump of coal, please?
I'm sorry, but as a character, I can't actually give you a lump of coal. But I can tell you that in the world of ice hockey, a lump of ice is a crucial part of the game.
The more you know. And one last live demo I'd like to show is using small VLM running in real time. So what I'm going to do is click Start here and ask it, what do you see? And in this case, it says, with its hands on the chest, word hugging face on the shirt. I guess that seems right. So that's great to see. And let's continue. I think 1 or 2 more slides. Just some final thoughts. I would like to say that there are endless possibilities, and I guess would want to encourage you to maybe explore with in-browser, on-device machine learning, and be able to share what you create. We'd love to see it. And if I leave you with one thought, it's always bet on JS. As Brendan Eich would say, first they said JS couldn't be used to build rich internet apps. Then they said it couldn't be fast. Then they said it could be fixed. Then it couldn't be multi-core GPU. Wrong every time. So his advice, always bet on JS. So naturally, I quote tweeted him and said, then it couldn't run LLMs. Wrong every time. And he seemed to like that. So I hope we're on the right track and being able to build cool demos with browser AI. And we'd love to see what you build. So thanks so much.